Welcome to the DIY Honda Garage channel. DTC P0967 indicates an issue with the CVT, continuously variable transmission driven pulley pressure control valve circuit regarding high voltage. This fault code is linked to the vehicle's electrical system rather than a mechanical failure within the transmission. Specifically, this error is often identified during diagnostic procedures utilizing the Honda Diagnostics System, HDS. The CVT-driven pulley pressure control valve assists in regulating the pressure within the continuously variable transmission. Accurate pressure management is vital for optimal CVT operation, enhancing performance and fuel efficiency. Notably, diagnosing DTC P0967 will require meticulous examination of the vehicle's electrical circuit connections and components associated with the CVT system. DTC P0967 pertains to the CVT-driven pulley pressure control valve's electrical circuit being high. The components primarily involved include the CVT-driven pulley pressure control valve and its associated wiring. This valve plays a crucial role in managing the hydraulic pressure necessary for effective transmission operation, impacting vehicle acceleration and shifting. It is located within the engine wire harness, connected to the PCM, powertrain control module, which interprets signals from the vehicle's sensors to manage the performance of the transmission. Therefore, a malfunction determined by this DTC signifies an electrical circuit fault, indicating that troubleshooting should focus on the wiring and connections rather than mechanical components. When diagnosing DTC P0967, several potential causes must be evaluated. First, shorted wiring can occur between the CVT-driven pulley pressure control solenoid valve and the PCM, leading to voltage irregularities. This could also indicate a failure of the solenoid valve itself, which may not function correctly under operating conditions. Another possibility includes outdated PCM software, which might not correctly interpret or manage current transmission parameters. Lastly, poor connections or loose terminals could cause intermittent faults, impacting the electrical signals between components. These factors must be systematically assessed during the troubleshooting process. The symptoms associated with DTC P0967 can significantly affect vehicle performance and driver experience. Drivers may notice poor transmission performance, characterized by delayed acceleration or slipping between gears. Increased engine load may also be felt, leading to reduced fuel efficiency and increased wear on engine components. Additionally, the illumination of the check engine light is a common sign, alerting the driver that a fault has been detected within the vehicle's systems. Overall, these symptoms can manifest as a combination of operational inefficiencies, making identification and resolution of the DTC critical for maintaining vehicle reliability. The first troubleshooting step is to begin with a verification of the problem utilizing the Honda Diagnostics System, HDS. After turning the vehicle ignition to the on position, it is imperative to clear any existing diagnostic trouble codes. Following this, start the engine and allow it to idle for at least 1 second. Once these steps are completed, check for any pending or confirmed DTCs using the HDS. If DTC P0967 reappears, it indicates a consistent failure, allowing the technician to proceed to the next troubleshooting step. If no codes are present, it may suggest an intermittent failure or a transient issue that could require checking electrical connections. In the second troubleshooting step, it's crucial to identify the possible failure area effectively. A direct test of the CVT-driven pulley pressure control solenoid valve is performed to ascertain whether it operates correctly under electrical command. This step is critical, since if the solenoid valve malfunctions, it would affect the flow of hydraulic fluid, leading to transmission issues. If the valve tests positively, indicating functionality, technicians can then move to the next step. Conversely, if the valve fails the test, this points toward potential replacement or further investigation into the solenoid circuit. Proper testing procedures will yield valuable insights into the integrity of the transmission control components. Step 3 involves examining the electrical integrity of the wiring. Start by turning the vehicle to the off mode, and then jump the SCS, Service Check System line, with the HDS. After this, disconnect both the PCM connector and the solenoid wire harness connector to isolate the circuit. Subsequently, switch the vehicle to on mode and measure the voltage between the specified test points. This will help identify if there is an unexpected wire short between the solenoid and the PCM. If voltage is detected under these conditions, it reveals a short to power in the wire, necessitating repairs to the wiring harness. If there is no voltage detected, it indicates that the DNLS, Diagnostic Network Line Signal, wire is not shorted, leading to subsequent checks. The fourth step focuses on testing for continuity within the wiring to further isolate the problem. Turn the vehicle to the off mode and ensure both the solenoid wire harness and the PCM connector remain disconnected. Continuity must be checked between specified test points to confirm the integrity of the DNLS wire. If continuity is present, it implies a short to ground in the wiring that needs repairing. If there is no continuity, it points toward the wiring being intact. In this case, technicians should consider updating the PCM software if it is outdated, or substituting it with a known good unit. The goal is to eliminate the likelihood of PCB or software-related issues before concluding the diagnostics. In the final troubleshooting step, the focus shifts toward checking the CVT-driven pulley pressure control solenoid valve itself. This involves removing the valve body assembly for access and disconnecting the solenoid valve's electrical connector. Technicians should measure the electrical resistance between two specific terminals of the solenoid under the condition that the vehicle is turned off. Resistance readings should fall between 4.6 and 6.3 ohms to signify that the solenoid is functioning properly. If the readings are outside this range, it indicates a fault in the solenoid itself. A failed solenoid would necessitate replacement of the valve body assembly. Should the solenoid test as functional, the next step would be to address any fault in the wiring harness connecting it to the PCM. Once repairs have been made regarding the DTC P0967, thorough verification is essential. First, clear the DTCs using the HDS to reset the system. After completing repairs, conduct a road test to evaluate the performance of the vehicle under various conditions. This helps confirm that the transmission is operating ranging from low to high speeds without any issues. Also, inspect for the return of the check engine light and ensure no new DTCs appear in the system. Successful outcomes will reaffirm that both the repairs and the reset process were effective, thereby reestablishing operational integrity to the CVT system. Preventive maintenance is crucial to avoid issues such as those identified by DTC P0967 in the future. Regular inspections of the CVT system and its associated components can help identify potential issues before they manifest as faults. Updating the PCM software as new releases become available ensures that any bugs or performance issues are resolved promptly. Furthermore, maintaining clean and secure electrical connections will prevent intermittent faults caused by poor connectivity. By implementing routine maintenance measures, vehicle reliability can be significantly improved, reducing the likelihood of similar fault codes appearing. In conclusion, DTC P0967 signifies an electrical issue related to the CVT-driven pulley pressure control valve. Identifying this problem requires meticulous checking of wiring circuits, including looking for shorts to power or ground. Consideration should also be given to the solenoid valve's functionality, as it plays a vital role in the transmission's operation. Using tools such as the HDS will facilitate accurate diagnostics and facilitate thorough testing steps outlined for effective repair. Ultimately, awareness of preventive maintenance measures will enhance vehicle reliability and longevity, keeping the Honda Fit 2015 to 2020 operating smoothly. Please like and subscribe to the channel. See you next time.